Lesson 46, going to learn a couple concepts. One we're going to expand on, and then we're going to learn a brand new one. The first one, we're just going to expand on the concept of radical expressions. So if we looked at these individually, we've kind of solved for these, but now it's just adding a little bit more to it for when we solve. So remember, if we have 3 times radical 5 over radical 2, right now we have, technically, it looks like this, 3 radical 5 over radical 2. That'd be another way of looking at it. If there's a radical in the denominator, that means it is not simplified. So in order to simplify it, we must multiply by radical 2 over radical 2. We multiply by the denominator in the form of 1. So now we get radical 5 times radical 2 is radical 10. So we have 3 radical 10 over square root of 2 times square root of 2 is 2. This is a plus sign right there, that's a plus sign. We've got to get rid of the square root in the denominator, so square root of 5 over square root of 5. Same process, we should know this. Square root of 5, square root of 2 is 3 square root of 10 over 5. Then we have square root of 90. We got to simplify that. So what are factors of 90? We got 9 and 10. 9 is a factor of 3 and 3, and that one has a factor of 5 and 2. Remember, we take 2 of the same, if they're the same, it becomes one whole number. And what is left, we put in the radical. So we say radical 5 times 2 is 10. So this could be written as minus 3 radical 10. And that's kind of the stuff we've done in the past, simplifying that part. Now we've got to add all these together. When we're adding them together, when we're adding fractions together, we always need the same denominator. We have to have a least common denominator. So what is the least common denominator between 2 and 5? Well, that would be 10. So we need to multiply by 10 over 10. If you remember a couple lessons ago, we talked about least common multiple. That would cancel denominator. Well, you can only do that with the equal sign. There's no equal signs here, so you have to have 10 over 10 in a sense. And when we multiply, the 2 and 10 would cancel to be a 5, so 5 times 3 is 15 radical 10 over 10. 5 and 10 would cancel to be a 2. 2 times 3 is 6, so plus 6 radical 10 over 10. Then we have minus 3 times 10, nothing cancels, 30 radical 10 over 10. Notice you could reduce these, but you just get right back to where we started. But we want it here because now we have 10 in denominator on all 3 of them. So therefore, and we have like terms on top with the radical 10s. So therefore we can add the 15 and the 6 to get 21. And subtract 30, 21 minus 30 would be negative 9. Radical 10 over 10. And that would be your answer. And so that's just expanding it a little bit, what we've done in the past. Just a little extra work. Now we're going to look at the second example. And I'll go through the initial parts like we've done. Got to get rid of the radicals, 7 over 7. So that becomes 3 radical 14 over 7. Same here, minus minus 5, 2 times 7, 14. Notice my radicals end up being the same. Now we have a plus 3 to the with the radical 56. Well, let's do radical 56 family tree right here. We got 8 and 7. I think that's 56. 8 and 7. We have 4 and 2. And 2 and 2. So we have one set of 2's we can take out. So we would be left with 2 radical 14 when we do 2 times 7. 2 radical 14. Now, what we're doing is we are putting this in place of radical 56. So we're saying 2 radical 14 instead of radical 56. So you got to make sure you multiply the 3 and the 2. 3 and 2, 6. And same thing we did in the last one. Find common denominator. Between 7 and 2 is 14. Multiply them all by 14. And you get, that cancels to be 2, so 6 radical 14 over 14. Let's see, that cancels to be 7, so minus 35 radical 14 over 14. And 6 times 14 is 84. 84 radical 14 over 14. And now you can add them together. 6 minus 35 is negative 29. Negative 29 plus 84 is 55. So positive 55 radical 14 over 14. So basically we're getting the numerators the same with the same radical. Denominators the same. So we can add the numerators together. So 55 radical 14 over 14. That's concept A. Now let's look at concept B. Radical exponents. Okay, so say we have square root of 3. I don't even know how to say this. Times square root of 3 in a sense. This square root is over both of them. Well, what we need to remember is square root of 3 is the same as saying 3 to the 1/2 power. Square root of 3 is the same as saying 3 to the 1/2 power. So what we're going to do is change this to a fractional exponent. So I'm going to change this square root of 3 to a 3 to the 1/2 power. I'm going to put that in parentheses. The reason I'm going to put this in parentheses is because only this one has this square root. Okay, so it's its own identity. Now this square root encompasses both of these. So how would we write that? Well, what we're going to do is put a 3 here. We're going to bring this 3 down, and I'm going to choose to use a bracket and put a 1/2 power outside of that. Because what a bracket would say is the 1/2 power is used for this 3 and that 3 to the 1/2 power. This being on its own says this square root is only used there. So now we can solve. So what we're going to do is, if you have exponents, if you have parentheses to an exponent power, remember what we do is multiply the exponents together. So 1/2 times, this is just 3 to the 1 power, so that would be 3 to the 1/2 power. When you do 1/2 times 1, we're basically distributing. And then you get 3 to the 1/4 power. 3 to the 1/4 power. From there, you can simplify one step further by adding, we have the same variable. Imagine if I said x to the 1/2 and x to the 1/4, you would know you could add those exponents together, exponents together. 3 is the same way. Same thing. So we add 1/2 plus 1/4. 1/2 plus 1/4, we would convert that to 2/4. We multiply by 2 and get 3 to the 3/4 power as our answer. Let's look at another. Well, we already know this would be 3 to the 1/2. We know that we would bring this 3 down. The only difference here is this one has a cubed compared to this one. So this one we put to the 1/2 power. This one, therefore, the bracket is to the 1/3 power because this goes over all of them. So it's to the 1/3 power. Then you distribute 3 to the 1/3. That's 3 to the 1/6. Add 1/3 and 1/6 together and get multiply this by 2 over 2 to get 2 over 6 to get 3/6. Well, 3/6 reduces to 1/2, so therefore this would be 3 to the 1/2 power. So that's using the numbers. Now let's look at if we have x and y variables. This actually may be easier because sometimes it can be confusing to look at that 3 and adding its exponents and whatnot. This one, we've done these variables in the past. Just a little different. So now, it gives two separate equations. It says we have x cubed and y squared, and they are in a square root. So if they're both in the square root, we can say both of them to the 1/2 power. Just like so. And then we have x and y both under the same cube rooted form. So we could say to the 1/3 power. Now, just like we did in the past, we distribute. 3 times 1/2 is 3 over 2. 1/2 of 2 is 1, so just y. X times x to the 1/3 power, y to the 1/3 power. So we just distributed everything. And now we add like terms. So we got x and x. Their fractions are 3 over 2 and 1/3. Oops, sorry. So we add 3 over 2 plus 1 over 3. Common denominator of 6. So if we multiply everything by 3 here, that would be 9 over 6 plus multiplied by 2 in that one, so 2 over 6. So you get 11 over 6 for x. So x to the 11 over 6 power. Then y, you have 1 plus 1/3. So turn this into a 3 over 3. Hopefully we know how to add our fractions because I'm kind of going fast for our fractions. So 3 plus 1 over 3 would be y 4 over 3. That would be your answer there. One more. 46.6, a lot of examples in this lesson. Just like we did in the past, x to the 5th, y cubed, all are cube rooted, so 1/3 power. X and y to the 5th are all to the 1/4 power. And then from there we just solve. We distribute x 5/3, y 3 times 1/3, or 1/3 of 3 is 1. 1/4 for x, and 5/4 for y. And so now we add 5/3 and 1/4. I'm just going to do this really fast. 5/3, 1/4. So to get the denominator of 12, multiply by 4. So that'd be 20 over 12 plus 3 over 12 to get x, 23 over 12. Now we're going to do y. We got 1 plus 5 over 4. It becomes a 4 over 4. Y to the 9 over 4th power. And that concludes, that's your answer, and that concludes